Hello guys, my name is Awal. I'm going to demonstrate how to delineate a watershed of a lake watershed with no outlet. Such lakes are called terminal lakes. So there are two ways on how to delineate such lake watershed. The first one is from the scratch, that is original. And the second one is it is simple, but you need some shape files of the lake, at least a lake. So let me start. I'm going to create a folder of the demonstration on the desktop. So start, I create a new folder and let me make its name demo for YouTube. So in this folder, I'm going to create my project. So I'm using QGIS 328. So this is a new project. So let me create a new project. That is a QSWAT, of course. And I'm going to save it on the demo YouTube that I've created already. And let me set it is probably with the same name or just YouTube like delineation. Let me call it like this. Yeah. So now just close this one and then uh, let me import my raster data first. Add layer raster. I keep it my name in here. So I have it my dim data here. It is called DM subset. Open it and then close the code. So this is my dim data. So layer styling, validated unique values, and I classify. So this is the lake. You can see this is my lake. To show you where exactly is located, just follow this one. Yeah, this is a Google hybrid. So you can see this is my lake. This is called Lake Hawassa. Lake Hawassa or Lake Hawassa. This is my lake. So as you can see, the lake has inlets only. Water flows from this direction to this. This is called this is the main river. It's called the Tukoroha River. So anyway, the unique characteristics of this lake is terminal. That means water flows into this lake, but it doesn't go out of this lake. So this is very unique. So delineating such kind of lakes is very much difficult. So I used to browse around the internet, YouTube, etc., to look for the mechanisms or the techniques on how to delineate such lakes, but I could not find one. But I managed to do it by myself later on after digging a lot. So this is my lake. So now just remove this one. So you see, if you use many tools of watershed delineators, this is very difficult to delineate because in many cases the water will flow to this direction. I use 6, 7 types of watershed delineator tools, but all are failing. So, so in this technique, I'm going to show you how to do it from the scratch, which is an original type. Of course, there is also a simple method, but in that case, you need some shape files, like you need to have the shape file of this lake. Let me assume I don't have this lake, and let me do it from the scratch. After layer styling, and after classifying the dim like this into separate pixels, what I have to first do is that try to understand the elevation of this lake. How do you do it? This is it. This is identify features. Now, this is band 1. This is 1684. So, every cell has its own unique value. Of course, this value is these values are the elevations. So this one, the lake has elevation of 1684. So bear in mind this one. Then raster, go to raster, clip raster by extraction, clip raster by extent, and then in here you clip extent. Itself. And the trick is that at this point, assign a specific lake node data, a specific node data value to outlet bands. So in this case, at this point, it is important to write this elevation mark, that is 1684. 1684. And then keep the rest as default and then run. But of course, before running, you have to save it to a specific name. Let me call it DAM lake node data lake node data. Wait a minute. Should be this. This is my folder that I have already created. So in this, I save it here in the format, in TI format. So the file name is dm lake node data. Save, run. So it's quick. Again, now I don't need this one. Again, styling now. Palette unique values. Make sure we are selecting this one. Palette unique values and then classify. Yeah, this is important now. Now this is it. See, now the lake has a band of no data, but unfortunately there are also there may be some other pixels with no data values. See, the surrounding do not have, I mean, they have their own values, like this one is 1686, but this one, the white cells, they are designated as no data. So this is the same as that of the lake itself. So that means, so these are voids. The lake has to be void. This is no data. It is wonderful, but you have to fill this. You need to have only water to drain to this void, but not to these white patches, white pixels. So the most important thing at this point is that you have to fill the voids other than the lake. You have to fill these voids. So how to do it? How to do it? Go to GDAL. GDAL, raster analysis, and then fill no data. This is one. And then here, make sure that you have the input layer, the dim lake no data, and then watch this point. Just I keep it default because the maximum is maximum distance in pixels to search out for values to interpolate. That means it is in this case it's 10. This is to mean that the words that is a white pipe, the white pixels have to be filled. Otherwise, water will flow to this white patch too instead of this one. Instead of the lake, water will flow towards the lake, towards this white patches or white pixels. So okay, you need to fill these ones. So in this case, by 10 means each pixel, for instance, this pixel will be filled using 10 cells surrounding it with the elevations of 10 cells around this pixel. 10, 10, 10, 10. Maximum distance in pixel unit. So you get this one, then simply run, keep the rest as it is. Now keep the rest default, and then save as dm lake no data void field 1 in the format. I say 1 in case I may have to repeat this same procedure. I will continue as 2, 3, 4, etc. So now 1, sorry, failed. Wait, failed. Sorry. I'll save in the same folder and I run. Watch out. Close this one. Now again, go to layer styling. By the way, don't need this one now. Now this one. So again, paletted unique values. Yes, so they are filled. Now, carefully watch out. See, the white parts are filled. What you have is only this one. The lake new data is the lake itself alone, but you have to check carefully. You should not have any white pixels, white cells. Otherwise, water will flow towards them too. Oh, it's dangerous. See, there is another pixel. Watch carefully. Yeah, you have also another pixels. See this data? This is 1685, and this one is your data. So water in the surrounding will flow towards this void, so towards this place. So you need to fill them. Of course, you may also have some additional you have also here. Oh, you have also here. So again, okay, what you have to do is you will repeat the previous step. You have to repeat the previous step. So how I do it, and then I go to fill your data in order to finish the remaining ones. Wait, like this ones. Fill your data again. Fill your data, and then keep as it is again. Defaults. Still this by this. It means this cell will be filled within 10 cells in every direction. The average of those 10 cells. So that is how this algorithm interpolates in order to fill these void cells. Save it again. So this is my second attempt. So this has to be filled out. Run. Load it. You don't need this one. And then here again, palette unique values, and then classify. Yes, it's gone. It was defined, but it's gone. Yeah, again, you can check again if you do not have anyone left. You should not have anything, any white parts, any white cell. I think I do not have anyone. I don't have any. Now, save it. Okay. Now what you have to do is just you need to click on this QSWAT, and it's already opened here. And then what you have to do is simply delineate the watershed. So here you have to, I have already selected. It is TM, this one, the one that we have already prepared previously. DAM lake node data void field 2 open. So then the next step is to simply you define the threshold. Let me do it using 9 hectares. Of course, you can make it more, but for this purpose, I need to make it at 9 hectare threshold level with 100 cells. So simply click this create stream. The stream network creation, it takes some time. So for that purpose, I'm going to pause this video recording and I'll be back when stream creation is completed. As you can see, it is creating the stream networks. It is working. Now it is done now. So now you can see there are a lot of streams that are already generated around the lake. So simply you can now you can observe all the stream networks are draining towards the lake. It's not draining into other cells. Simply every cell is draining towards this towards the lake. So this is very much important for me. If you do not do this step, for this case particularly, as the lake doesn't have any specific outlet, previously it used to flow in this direction. Of course, that is completely wrong. So every water has to be drained towards this the center of the lake. This is important now. Then what I'm going to do is simply I'm going to create this watershed. So for this purpose, I'm not going to do anything in here. Simply I create a watershed using this stream networks and using this the lake as an outlet point. So simply create watershed, click on it, and then you can see a watershed is being created or delineated. So again, it is going to take some time. For that purpose, I need to make it and to pause the recording, and I'll be back when it is finished. Of course, it doesn't take a long time, but I'll be back. Yeah, it's nice. It's already completed. As you can see, the watershed is already delineated for each stream network for the entire dam that I gave to the SWAT model. So at this point, what I'm going to do is that just I need to look carefully at only the part of the streams, the stream network that are flowing to the lake, to my lake. This is a lake. So what you have to do normally is just differentiate between the stream networks or the watershed that are draining to your watershed and then to the lake, and then other than the lake. So as you can see, this is the watershed divide. This is the watershed divide. So after this, the water is flowing opposite of my lake, as you can see. But in this case, these blue lines is draining to the lake. So what I'm going to do is that I'm going to differentiate between these two. I'm going to erase or delete the part of the watershed that are draining outside of my country. So I need to delete this watershed. This is simply by using editing. So what you have to do is simply come here and then toggle editing on it. After you make on this toggle editing, then you go to this selection select feature by area, and then come here. Mind you, this is a watershed divide, so I don't need this watersheds. Carefully do this and then delete from your keyboard. Delete. So this is, it needs, of course, it is time consuming, and then it needs a lot of attention. So this one, delete from your keyboard, and then like this. This is also draining to opposite of my lake. This watersheds, I'm going to select and delete. Okay, this one too. And then I come here. Careful, take care. You see these watersheds? These are draining to my lake, so I don't need to delete them. And then I come here. Okay, take care. This one is myself. I don't need this. This one too. I don't need these ones too. And these ones. Yep. So simply you have to do this carefully around the lake. Let me do it by myself, pausing the, and I'll be back when I've done it completely. Okay, now as you can see, it is already completed. The entire watershed is delineated. As you can see, I have included all the streams that are draining in my, towards my lake, and the other watersheds and some watersheds draining outside of my lake are already excluded. This is important. This is nice now. So, as you might see from the shape file, you can see there are a lot of sub watersheds. So there are around 7,225 small polygons. So there are a lot. So I don't need all this. So I need to merge them into one shape file. So what I have to do is come here, come to dissolve. Yeah, it is located in this GDAL. So yes, I come here. Now instead, come here, vector, geoprocessing tools, and dissolve. Here, make sure that you are selecting this my watershed, and then come here. Maybe you can save as let me make the file name as I can give it this name. So I prefer to give it a name as lake delineation SWOT output in shape file format, and then click on save. I have already previously done it, so that's why it is popping up. And then now click run. At this point, it gives you a warning, an error warning. It says that you need to fix the geometry. So what you have to do in this case is that go back, come here, advanced options, and then invalid feature filtering, and then select this one, do not filter, and then now you can run. Yes, it is done. Now this is now what I need. So as you can see, so you have now created a single watershed. Yeah. This is one. And after having this, now what you can do is just you can clip this raster by using this mask layer, and then come raster and extraction, clip raster by mask layer, and then your input layer is this one. where fill 2, and then your masks layer is lake delineation. No, I think the CRS should be according to my project CRS, and then at this point minus 9999, and then you can keep it the rest as it is and give it a file name with the same file name as the shapefile, lake delineation. So lake, yeah, I've already previously done it, so that's why this name is popping up. So I give the same name as the shapefile. So lake delineation is what output .tif. Save it. Let's replace it and then run. Yeah, this is already done now. So these are what we need. The shapefile and the raster file. Now using these two files, you can rerun the SWAT. Okay, open this QSWAT. Sorry, it's already done. Your file name should be it should be this one, not the previous one. So come here and then I saved it here, I think. Lake. This is my raster file. Open this. Okay, sorry. And then now at this point you can make it you can use any threshold value, but for this purpose I'm using 100. It's no problem. 100 hectare. And then you can, of course, you can use any threshold value depending upon your requirement, depending upon how detailed you want to see these streams and the watersheds. Just for this demonstration purpose, I'm going to use the 100 hectare with this number of cells. And then now I can create stream. Yeah, it is generated. Streams network is generated. That's nice. Now you can use this for your purpose. You have the stream network, and then you have the share files. This one is share file. This is a watershed now. Of course, you can create your own tool, create a watershed for the new stream network. It takes some time. Yeah, this is already done. So you can click OK if you want to give the SWAT numbers for each sub-watershed. Otherwise, you can cancel. Now this is it. Now this procedure shows how to delineate a lake watershed without any outlet. That means a terminal lake. This is how you do it. For your information, I'm using QGIS version 3.28.13, and then the QSWAT is 3.9 is a version of 1.6.5. And my machine is with Core i7, Intel Core i7 with 8 GB RAM, and it is Windows 11. Thanks for watching.